the only way to really know if a chemical reaction has happened or not is by analyzing um, the properties of the substance to get afterwards or after the change has happened. And if you get new physical property and or chemical property, that means you have made a new substance. But not always are we able to go ahead and analyze the new substance and determine new properties. So in chemistry, what we can do is often to make predictions, we can look for signs or some evidence that will suggest if a reaction is going, if a reaction, usually in chemistry, when we use the word reaction, it means chemical change, but rather if a change is going to be chemical or physical. If you do observe signs like burning, gas, smell, smoke, bubbles, fizzing, or foaming when you mix two substances, or any one of these other ones, which might not be so obvious, then there is a very high chance that you have a chemical change, especially if you observe more than two or three. And if you're simply observing things like shape change or state change, slash phase, then that's usually a good sign of just a physical change. So if we look in this list, um, when paper towel absorbs water, that is simply a physical change. If we just squeeze out the water from the paper towel, we should be able to get our water back and get the paper towel back. So usually a physical change um, is a situation where things are changing their size, shape, or state, but no new substance is being formed. And a chemical change, you will have um, things, new substances being formed, or new things that were not there before. They usually will look different. Going back to this list, this table of signs of a chemical reaction or physical change. If you do observe new color or new solids being there that were not there before, new stains or rusting, new smell, things of that nature, usually that indicates that we have a chemical change. And in a chemical change, things will change their physical and chemical properties. So let's go back to example number 16 here on the practice guide. So on this exercise, so when paper towel absorbs water, again, the paper towel is still paper and the water is still water. We're not destroying water and we're not destroying the paper towel to make new substance. However, if we are to burn paper, that would be a chemical change because the paper is now ash, and ash we can recognize has properties that are completely different than a regular paper. And the first example in this case, NaCl dissolving in water. Anytime you see dissolving, that is usually just physical change, because when things dissolve, the particles are really just hiding between each other, but there's still the molecules or the particles are still the same. They're just being mixed up, but you can usually get them back without having to make too much effort. As far as silver tarnishing, or if you have a piece of, you look at a piece of silver, and when it's brand new, it's shiny, but then later on, it's not shiny. It looks like it's grayish, dull. That's when silver tarnishes. So we have new substance on the silver that wasn't there before, so that's a chemical change. When an apple is cut, that's just a size change. You're just having going from a whole apple to a smaller piece of an apple. It's still apple, so that's just a chemical change. When the heat is being changed into steam, that's just again a state change. That's evaporation, boiling slash evaporation. So anytime you have state change, we know it's just a difference space in between the particles that's happening. So that's always just about always going to be physical change. When baking soda is react to vinegar, usually we will have some of the signs like Spontaneous change in temperature, the temperature will drop. You get gas. You get bubbles, fizzing, foaming. So we have a bunch of evidence that will suggest that that's a chemical change. When iron rusts, we actually have a image of this. When iron rusts, this is what pure iron looks like, or iron nail. And when it rusts, you can see that you are making new substance. It looks completely different. You have this particle right here, this atom that was not there before, in the original iron, and that's in there now. And rust smells different than the iron. It's a lot weaker, and you can go through the table with the properties and look at them and find other signs that will point that it's a chemical change. When alcohol evaporates, again, the key word here is evaporation. That's just a state slash physical change. Melting, state slash phase change. So both of these are physical. A milk sour, when milk goes bad, it smells bad. It looks bad. You can't, if you drink it, you're probably going to get sick. um, and the color looks nasty. You might even get some mold in it. So that is definitely chemical change. When sugar dissolves in water, again, anytime you see dissolving, that's just a physical change. When wood rots, it's kind of like when milk goes sour. The wood becomes very weak, and you might get mold. It smells different. It's completely different than its original state. When pancakes cook, anytime you see cooking, that is going to be a chemical change. Pancakes were before they were soft, now they are hard. Where the the pancake batter will taste different than the actual pancake that you're eating. The smell is going to be different, and there are other signs that you can observe. When grass growing, you can argue that that's both. Its size is changing, which is physical, but also in order for grass to grow, it has to go through photosynthesis, which is a chemical process. And when a tire is inflated, that's just a physical change, just adding air to the tire. If we take the air out, the tire is going back to its original position. And when food is digested, that is a chemical change because the food is being broken down into your stomach into completely different um, particles or that your body do need for nutrition.